Okay, so thank you very much for coming. It's a pleasure for me to see so many people and so many young people here. It's very clear that the topic of this seminar is of great interest for many people. And this is one of the reasons why the Scuola Sant'Anna, the Scuola Normale, and the youth school in Pavia decided that it was time for these three schools to invest in climate change. I don't know whether we can say we can invest in climate change, but it's a topic we should be in, and we should address this challenge for our planet. And this is the first public event in the framework of this initiative, which is a shared initiative among the three schools. And it's, for me, a great pleasure to welcome here Professor Brian Hoskins. Brian Hoskins is graduated he has a degree in mathematics from the University of Cambridge. He spent several years in the US. And he is now Professor of Meteorology at the Imperial College and at Reading University. He is also the first director of the Grantham Institute for Climate Change at the Imperial College in London. This institute exists since 10 years. And it's, for us, a reference for trying to learn how to establish a research institute about climate change. What should we do, which mistakes we should avoid doing in establishing an initiative about research and, of course, education in the field of climate change. I will keep this introduction very short, therefore it's my pleasure to give the floor to Professor Hoskins. Thank you very much.
Well, thank you very much. It really is a great pleasure to be here. I've enjoyed being a tourist this morning and then speaking to you this afternoon, and to combine those in Pisa is very nice. So I want to talk about the challenge of climate change. I'm going to make that challenge, look at it in breadth, so I will be looking at things like the technology, the politics, and maybe the economics and maybe health aspects if I can get to all those. But I do want to start off with the science as well. And I'm sure not all of you are scientists, but I'm sure all of you should have a grasp of the science that's behind this concern on climate change. I mean, it's something that we should all be aware of in order to know just how firmly based this fear of climate change, if it's not tackled, how firmly based that is. So I'll be talking quite broadly about climate change, but here we start with the science. And I'm really going right back to square one here. That's planet Earth, that blue planet over there, and that's the sun over there, not quite as far away as it should be. And that's the solar radiation coming down to us from this very hot body, the sun, which means that's quite short wavelength, that radiation, peaking in the visible part of the spectrum. And because of that energy coming towards the Earth, then the Earth heats up, and then it gives off radiation. It emits in the long wavelengths because it's a much cooler body, and so that's essentially giving off heat. So we have the shortwave radiation coming in and the long wave radiation going out. And in that sort of balance, where there's as much coming in as going out, then the temperature of the Earth would be about minus 18 Celsius. So it wouldn't be a very pleasant body, and we wouldn't be here today in Sant'Anna. So that's not good news. And we come to the good news now, which is the greenhouse effect. So I'm going to say this is wonderful stuff that we have the greenhouse effect here, because the solar radiation comes down on the Earth, and we have in the atmosphere these so-called greenhouse gases. Not a great name, but they do have some effects, a bit like a greenhouse. And what they do is let this shortwave radiation from the sun come straight through, so they're totally transparent, so they don't stop any of the sun's radiation coming down on the Earth. But the heat given off by the Earth, which is long-wave radiation, is actually absorbed by those greenhouse gases. So they're transparent to the solar radiation, but they're opaque to the Earth's radiation, the heat given off. And so they then transmit that, they emit that radiation in both directions, and eventually the radiation escapes to space. But because they radiate back to the Earth. The Earth heats up more because at the higher levels of the atmosphere where they emit, I hope this does work then, so we'll see if that works there. That's not going to work, is it? Okay. Oh, it does work there. Okay, so the radiation to space then happens at the higher levels of the atmosphere where it's colder. And if it's colder, it gives off less heat. So this has to eventually balance this solar radiation coming in. And in order for this to actually balance the solar radiation coming in, the Earth has got to heat up more. And then there's enough radiation escaping to space to let the balance occur. So it's the greenhouse gases that do this. And because of those greenhouse gases, then the temperature of the Earth is about 33 degrees warmer than it would be, plus 15 rather than minus 18. So that's really good news. And these great greenhouse gases that do this, well, the number one is water vapor. Now, you don't hear anyone saying we must stop producing water vapor because it's going to harm our planet in terms of climate change. And the reason that is, if we put any water vapor into the Earth, it cycles on a timescale of about a week, and it will just rain out. So we don't directly affect the amount of water vapor in the atmosphere, although indirectly we can through the other greenhouse gases. And the next one then is carbon dioxide. And that's the one you'll hear most about because that's the majority of the greenhouse effect, apart from water vapor, and certainly the one that we're influencing directly. But after that, there's methane, nitrous oxide, and many others down, giving a less effect. This is not new science I'm talking about here. Fourier knew that there must be something like this because the Earth was warmer than it should be. And Tyndall, who was actually a forerunner of Imperial College when he performed the experiments to show in the laboratory that a gas like carbon dioxide or water vapor does do exactly this, that it allows the shortwave radiation through but absorbs the long-wave radiation. So this was shown in the laboratory in the 1860s, and Arrhenius in Sweden used these ideas to actually look at the ice ages, but then also sort of gave some idea of how much warmer the Earth might be because of the carbon dioxide being emitted. So we're talking about 19th century science here. Now, what's happened about carbon dioxide then? I mean, that's the next slide here, which shows since 1957 on a mountain in Hawaii, the actual measured carbon dioxide. I always think it's amazing that someone managed to persuade the authorities to fund them to go to Hawaii to measure carbon dioxide. So every day they would go up the mountain, measure carbon dioxide. In 1957, when not too many people were worrying about it. But anyway, it is now fantastic that that was done. The amount of carbon dioxide in the atmosphere is about 300 parts per million. So 1 part in 3,000. Not a huge constituent, but a very important one. And you can see since 1957, there's an annual cycle here, and we understand that it's associated with there being more vegetation in the northern hemisphere that soaks up carbon dioxide in the spring and then breathes it out in the autumn. So that annual cycle is a measure of what the vegetation is doing. But then you can see this upward trend here. So in the time since it's been measured here, this was last week, and we're now about at the 410 level, whereas we were back here below 320. So it's a very significant rise on this. It doesn't matter where you measure carbon dioxide in the atmosphere because its lifetime is so large it gets mixed. So the measurement, unless you're close to a chimney, will be rather similar. Now to put that in context then, here's the same curve. I haven't taken it quite as far as we're now up there actually. But this then goes over the last 1,000 years. And you can see since the Industrial Revolution, then this is the rise that's occurred. Before that, it was pretty level around 280 parts per million. And then if you go back further, in the ice ages, on the last million years, it's oscillated between 180, somewhere down here, and 280 on a time scale of 100,000 years or so. So we have taken, I say we have taken because that's going to be the next point, the rise in carbon dioxide is due to us, mainly due to the burning of fossil fuels. There are many ways you can show that this is the case. The amount there corresponds to about half of what we think has been emitted during that period. If we measure the amount of oxygen in the atmosphere now, the amount of oxygen in the atmosphere is actually decreasing slightly. You don't need to worry about it. But it is decreasing at a rate which is consistent that carbon is being combined with oxygen to produce CO2. And then if you look at the isotopic signature of the carbon dioxide in the atmosphere, again, it's consistent that it comes mainly from fossil fuels, the addition. So it's due to us, and it's a long-term problem. We can't just say, well, in a few years' time, we'll stop doing it. For every 100 tons of CO2 we put into the atmosphere, come back in 1,000 years, almost half is still going to be there, as not the same molecules, but actually the perturbation of the level. So it's a long-term problem. It's accumulating what we're doing, and it's something we couldn't have anticipated back in the start of the Industrial Revolution. Coming from Britain, I better say that, because we're rather the start of the Industrial Revolution, but I don't think we're to blame too much because we didn't know what we were doing. But we do know what we're doing now, and this is due to us. Right, so adding carbon dioxide in the atmosphere, as we've seen from the previous slides, is then going to warm the atmosphere, the climate system more. The Earth will warm. And the only question is how much, not whether, just how much. It isn't just carbon dioxide, I said, there's other greenhouse gases, and this is not an exact statement. They aren't equivalent to carbon dioxide, but effectively they add about 20% more than the CO2 we have. So these are important as well to think about, but mainly I'll be talking about carbon dioxide. So the greenhouse gases have risen. What about the temperature? Well, this is temperature. There have been people measuring temperature around the Earth for hundreds of years, and you can put together a temperature curve even way back to about 1880 with some confidence. There should be an error bar around this, but you can see fluctuations. This is a globally average surface temperature wandering around. There was certainly a hot period during the 45 or so, but then since the 1980s, the late 70s, you can see the takeoff here. Now, it's a typical curve that you get from any environmental thing here and from many other aspects in society, that if you take a particular decade, such as this period here, you could say, oh, the temperature's not going up much. It's all over. It's all been a fairy story. It's just not true. But if you take the longer-term view over timescales of 30 years or more, then you see this inexorable rise in the temperature. And we're somewhere here, that was 2017 there. So the temperature is going up, and it's going up by the amount that a back-of-the-envelope calculation or a supercomputer calculation would suggest is about consistent with the greenhouse gases. Now, that's the globally average temperature, but it's important to look locally. And if we do that over the 20th century, from the earlier 20th century to the late 20th century, then we're looking, if we look globally, we can see what the change is. And globally, it was about 1 degree. And if we look at this picture here, you see that over the oceans is typically much less than 1 degree. And we understand that because the oceans need a lot of heat to warm them up. The thermal capacity of the top 2.5 meters of ocean is equivalent to the whole atmosphere above it. So it takes a lot to warm up water. And so the oceans heat up much slower. But over land, you can see it's almost everywhere much more than 1 degree. And even over the tropical continents, it's 1 degree or so. But over the northern continents, then we're looking in maybe up to 2 degrees. So it really is a global warming in the sense that it's happening almost everywhere, but it isn't a uniform warming. But a warning to us as over the land surface, the change is larger and quicker than over the ocean. I haven't got time in this talk to look at too many curves of what's going on, because I want to get to other things as well. But over on the left there we have sea level change. So it's, again, the global average of sea level change. And this has been measured from satellites in recent years and further back. Actually, this is from the satellite era here. And you can see it going up. It's about 3 millimeters per year. That doesn't sound much, but it's 30 centimeters per 100 years. That's the sort of rate of rise in this period. And there's even evidence of maybe of some acceleration in the last period. And in the earlier time, then, this was mostly due to the expansion of water as it warms up. So the oceans, they don't expand much, but they do expand enough to raise sea level as they warm up. And then there was some from the glaciers melting as well. But in recent times, satellites have been able to measure the mass of the ice sheets on Greenland and Antarctica. And now there is a measurable contribution to this from the melting, the reduction in those ice caps in Greenland and Antarctica. So they are now contributing to this rise in sea level. And I've put in one other curve here, which is Arctic sea ice area, because that is an important indicator of what we're doing as well. So the sea ice in the Arctic grows all the winter in extent and thickness until about March, and then it reduces in thickness and extent through to the end of the summer till about September. And I'm showing you here the area of that sea ice in September, the minimum area. And that number is 8 in millions of square kilometers, and that is 4. And you can see the curve down. Again, there's lots of fluctuations here, and some people will emphasize when it's low, and other people will emphasize when it's high, but really we should be looking at the long-term trend. And if that continues, then the Arctic sea ice will disappear sometime around the middle of this century in September. It will grow again in the winter, but it's an indication of what we're doing to the climate system. Going along with the change in temperature has also been an increase in extremes of rainfall and changes in rainfall. And let me give you just a brief scientific thing against why you would expect more extreme heavy rainfall. A warmer atmosphere can hold more water. If the atmosphere is 6 degrees warmer, it can hold 50% more water. So it's a hugely nonlinear thing. And what we find is a warmer atmosphere is possibly to hold more water, and in general it does. So if we warm the climate system by 6 degrees, then the extreme rainfall event, the same storm, would give 50% more rainfall. So that's a very simple argument, but we find around the world that this extreme rainfall is increasing in many regions. And I've put a few UK records here which may not interest you too much. They interested us at the time. There's major flooding events in various areas around the world. Those were very severe events in India and Pakistan. And I've mentioned one here too, the Middle East. Before the problems in Syria and many of the areas of the Middle East, there was a severe drought which had major impacts on agriculture and on the whole communities. And it's not the cause of the insurrections, the problems going on, but it is a major contributor to there, and how it was handled by the authorities. So again, like the French Revolution, the failure of the harvest in France was not the cause of the French Revolution, but it was a contributor to the problems that occurred actually at that time. Also, tropical cyclones. Again, let me give you a simple scientific basis of why we would expect more severe tropical cyclones. The energy source for a tropical cyclone is the warmth in the ocean. So it's the warm tropical oceans that provide the energy for a tropical cyclone. So if the ocean warms up more, there is more potential energy for a tropical cyclone. Not that everyone will be stronger, but there is the potential for the stronger storms. And these are a number well, that's a strange one because it hit New York. They don't usually. I thought something like that might be enough to persuade the President of the United States always that this was a serious problem, but it doesn't always work. This is the most severe storm in the Eastern Pacific region. This was one that, higher than 2013, the most severe landfall winds recorded in the Philippines, causing all sorts of problems. And this was part of the Atlantic tropical cyclone season last year, which created all sorts of problems. So there's many examples of tropical cyclones tending to be more severe now. As I say, not every one, but there is the potentiality. But it isn't all the one way, and these are a couple of things that happened last winter. So last winter, there was a spell when the eastern US and the Midwest was incredibly cold. This is 15 degrees below normal, 12 degrees below normal. And so there was lots of sort of things in Washington about where's the global warming now, so if only we had a bit more global warming. But of course, if you look at the whole hemisphere, then actually it is still warmer than normal. There's great warmth here in the Arctic as well. And then Europe, we had a very cold spell as well. This is in the end of February. But again, the hemisphere was still warm. So weather events can give severe changes in certain regions, and we still don't understand whether the severity of these cold, the fluctuations, may be an indication of a changing climate, but it's not known at the moment. So it isn't always warmer. It can be cold, and maybe that's influenced by climate change as well. Now I want to talk about the future. I've taken more than I intended on that. But how do we go about projecting into the future what climate change might be like? Well, first thing is we use climate models. Now, these models were developed from weather forecast models. They're based on Newton's laws of motion, the equations of thermodynamics. It's not to do with statistical relationships or just simple theories or correlations. It is actually based on the sound scientific principles. And those weather forecast models have been extended to the deep ocean and to include ice and the behavior of ice, the behavior of the land surface, the behavior of chemicals in the atmosphere. And so these models are tested on past climates, on fluctuations we see in climate now, and then evaluated to their behavior, and then projected forward to the future. But if you're going to do that, I use the word projected rather than predicted, because we have to say, well, what will the emissions of greenhouse gases be? And so we take a particular scenario of the emissions of greenhouse gases and say, well, suppose that is what is the human beings do in future, and then what would the climate change be? And then this is from a range of models in the Intergovernmental Panel on Climate Change report in 2013, and a range of models saying, well, the top curves, the pink ones, red ones, are saying, well, suppose we go on emitting as we are at present. Now, this is often called business as usual, but I think you'll see the impacts are so large that actually business would not be as usual. It's impossible to have the business as usual curve. So if we went on emitting like that, many of our activities would actually fall away and be impossible. But suppose we did, then the rise in temperature from the 2000 period here is about 4 degrees, maybe plus or minus 1 degree. And that was already 0.6 degrees larger than the pre-industrial. So we're talking about from pre-industrial something like a 4.5 degree temperature rise on there. Whereas taking another scenario where the greenhouse gas emissions are severely capped and then reduced, then this rise could be at the level of 1 degree or 1.5 degrees or maybe 2 degrees. That's a lower curve there. So that's what the globally average temperature looks like according to models if we do 2 of those scenarios. But I want to just emphasize that it isn't global warming, it's climate change. And we should look again at the distribution of that temperature change. So if we took that upper scenario where the temperature change was 4 degrees on average, then over the ocean, as we expect, it's almost everywhere less than 4 degrees. Over the land, it's more. So over the tropical continents, it will be 5 degrees warmer. On the warmest places on the planet, it will be 5 degrees warmer. Now you can think of the impact on human activities in pre-monsoon India, where it's pushing 50 degrees, and you add 5 degrees on, then human activity becomes impossible during the day, basically. So huge temperature rises here, but then in the northern continents, this is maybe up to 10 degrees, even though the globally average temperature rise is 4 degrees. So we're speaking of large temperature rises there. You can imagine the impact on the permafrost. It would no longer be perma. So melting of huge things here. But it isn't just taking today's weather and adding 5 to 10 degrees on, because weather depends on temperature contrast. And you can see here the temperature contrasts are changing. And that would mean that the weather is different as well. So it's different weather in a much hotter climate with more extreme rainfall and changes in rainfall. And one indication of that then is this, to show the soil moisture changes, because that gives an idea of the impact on agriculture and maybe the availability of water for all our activities. And you can see those red regions, which includes the Mediterranean, and so Western Australia, Southern Africa, southwestern US, and maybe the Brazilian South American region there. These are areas where the soil moisture is predicted to decrease very significantly. So that's all on the high emission scenario. I'm going to show projections for 2 other quantities as well. Again, not to show too much, but sea level rise, we've talked about that already. And on the high scenario, this is of the order of 0.8 of a meter from 2000. So if you add on the past, this is something like a meter sea level rise by the end of the century. So I talked about 30 centimeters per 100 years. This says there's an acceleration from that to the order of a meter. But, and there is a but here, when this was done, there was no idea of an acceleration in the melting from Greenland and Antarctica. And many estimates say this could be pushing the 2 meters sea level rise. So again, you think of the impact on many of our coastal cities, which are built on that 1 or 2 meter level. And of course, again, when the weather actually has the onshore wind blowing, then it's not just the 2 meter rise, it's the same sea level, but then same winds blowing on a much higher sea level rise. A lot of the damage from Sandy in New York was because the sea level has already risen 20 centimeters. So the sea level much higher, then you get the overtopping and much more damage than before. So that's sea level rise. And one other thing to show then is the acidity of the ocean. And as carbon dioxide levels increases in the atmosphere, more gets absorbed into the ocean, and that interferes with the biology of the ocean, in particular those animals in the ocean with shells. And so on the high scenario, this is a significant change in the acidity of the ocean, whereas on the lower scenario, maybe it's something that more of those creatures could deal with. So I've sketched what's happened already, the science of climate change, and the sort of things about the future. And they're based on such hard science, it's a job to say they're going to be wrong by too much. So what about the impacts? Well, and there's been a lot of work on the impacts, and if you take the sort of things we've looked at, then on the high scenario, billions of people with increased water scarcity, river flooding, plant species, greater than half the habitat loss, 60% of cropland less suitable for agriculture, the demands from cooling, which of course will make the problem worse, and billions, tens of billions of people exposed to heat waves. There's other things one could put. There's also There's the spread of tropical diseases and the impacts of those. So there's impacts in the medical area as well. So huge areas there. I do want to put this in the wider problem too, about essentially us living on this planet. And the part of the wider problem is the growing world population, probably going from about 7 billion now to maybe 10 billion. A lot of that population moving to the cities, the move to a Western diet in many countries, which is much worse in terms of the greenhouse gas emission, increased demands on the system, and all the other global environmental changes. Now, climate change is one of the UN Sustainable Development Goals agreed in 2015, but it influences many of the others here. In fact, almost all of them: clean water and sanitation, gender equality. Well, if there is more gender equality, it might help with climate change, but good health. There's many of the rest of the Sustainable Development Goals. And I think climate change has got to be looked at in the context of all these to make sure the actions taken are things that help in many areas rather than helping climate change but hindering some of the others. So, to summarize then the anthropogenic climate change problem, and the impacts I've shown you are actually what I think we get if we're lucky, because they come from taking all these models, which don't tend to be very sensitive to the changes in the basic parameters. If you use those models for the 6,000 years ago, they can't get the green Sahara, for instance. They don't like shifting too much from today's climate. And so I think, if anything, they tend to be too smooth in their behavior. So the impacts are what we get if we're lucky. In fact, there's increasing chances of crossing thresholds in the climate system. There's many aspects of the climate system, whether it's the permafrost release of methane from the permafrost, maybe it's to do with the Amazon rainforest, that as the drying goes in that region, that rainforest can no longer absorb the carbon dioxide. Many aspects of the climate system, the ocean, the overturning circulation in the North Atlantic, that keeps us warm. It's a strange thing if actually Europe doesn't warm up as much as the rest of the planet, because the oceanic circulation stops in the North Atlantic that keeps us warm. There's all sorts of thresholds we could cross, and we really don't know quite where they are. But there's thresholds in the natural system, in many of the plants and animals, how much climate change they can really take. And in social systems, as I talked about India, for instance, and many other cases, there becomes a point at which you cannot do any more what you're used to doing. And in the past, people would have migrated across boundaries. The boundaries weren't there. We didn't have countries. But now Bangladesh is there. The sea level rises. The tropical cyclones come in. India is not going to say welcome across our boundary. So the ways of coping with these things are not really there. So we're performing a very dangerous experiment with our planet. If we had 20 planets, you might say, okay, let this go ahead on one of them. We'll see what happens. But we only have one. We're dependent on it. And to our species, it really is an existential threat, in that, as I suggested in the Middle East, the danger of climate change is perhaps that it will contribute to these the disturbances in society and between countries. And so the threat to our species is there, and the threat to other species on this planet. And in fact, there are some people who would say that the threat to the human species, if this really wipes us off the planet, that's no problem to planet Earth, and the rest of the planet can return to how it would like to be, and it's just got rid of us, and that's maybe not too good for us. So what can we do about it? And I'm going to go through these in the time I have. So the first thing we can do is adapt, and I'm going to say we certainly must adapt. So the climate is changing, and there are many extremes today that in many parts of the world they cannot cope with today's extremes. So that's number one, is to deal with the extremes today. But then the second part is then planning to deal with the future extremes in climate. I'll give you one example from my home territory, the Thames Barrier. You might know that on the River Thames, to stop London flooding, there is a barrier that was originally expected to be working a couple of days a year. It's now working most days of the year. But there are planning for the next one, and those plans could be able to cope with a 2-meter sea level rise, and that's the sort of planning that has to go on. So adapt we have to do. Then the next one is to do something else to compensate. Well, we're putting carbon dioxide into the atmosphere, and that's number one here, that we could try and remove it. Well, anyone who knows anything about thermodynamics will know it's much easier to stop carbon dioxide getting into the atmosphere than to remove it once it's there. But there are some things that you can do naturally, and the green ones here are things one can do to do with the vegetation or to do with the soils. So those are all things we can do to try and help the land surface absorb more carbon dioxide. There are some suggestions perhaps to do with the ocean, that you could help the absorption of the ocean by the biology, but I think those have been really ditched now. And some people say we could help the land surface, but you couldn't do much, I don't think. And then there's direct air capture, which would involve huge amounts of energy, but it is being worked on as a technology. So it might be that in the Sahara Desert with solar power, you could get enough energy to power technologies to remove carbon dioxide from the atmosphere, and then either use it or certainly liquefy it, use it somewhere else, or else put it underground. I mean, it is possible that some of that could be done. Or actually growing plants and then capturing the CO2 when you burn them, and again putting it underground or using it. So there are things you can do there, but very difficult to compensate any more than a small amount of the carbon dioxide we put in the atmosphere. There's another one here which is reduce the sun's energy reaching us. Well, you remember what I said at the beginning is we're stopping, we're allowing all the sun's energy through, but we're stopping the heat escape. So some people have said, well, why not stop some of the sun's energy coming in? Now, so you could do that in a number of ways. So you could put some sort of umbrellas in space. So that's here, where you put up these things in space and try and stop some of the sun coming down. You could put particles into the high atmosphere, like volcanoes sometimes do. And we observe that those do really cool the climate system a degree or so. And you could try and change the reflectance of low clouds, or you could try and do something on the surface. I think, well, the favorite one of most people who like this is to do this. If you put particles into the stratosphere, you interfere with the chemistry of the stratosphere, you get some beautiful sunsets. You may manage to balance the globally average temperature, but you would not stop the change in climate because the distribution of energy would be different. And once you start doing this, you'd have to keep going for thousands of years. Otherwise, as soon as you stop, all that extra heat would suddenly be realized and the temperature would rise rapidly. So we would give a legacy of future generations of having to keep going like this. So it's not as I'm suggesting to you, not my favorite solution. And then the last one is we should stop emitting these greenhouse gases, which is often called mitigation. So what's been done on this? Well, internationally then, there's been the United Nations Framework Convention on Climate Change, and that's been meeting since 1992. The Rio Summit, Earth Summit in 1992, set this up, and they decided they were trying to stop dangerous climate change. And it's only really in recent years that has taken the form of saying, well, the temperature rise should be less than 2 degrees. So there were many meetings of these parties, so-called. This was not a sort of gin and tonic party. This was the countries of the world meeting to try and decide. I was in Copenhagen when they failed completely, and then in Paris, eventually, there managed to be an agreement to stop the temperature rise less than 2 degrees and with an aspiration of 1.5 degrees. And the difference coming to Paris was the countries were asked, well, what will you pledge to do? Well, not this is what you must do, but what will you voluntarily say that you will do? And it wasn't just a target for the future. So there's going to be a return every 5 years to try and get peer pressure to up the amount that countries will do, to try and make them do more. Now, developing countries need help on this, and the rich countries of the world pledged that they would help in this. This came into force in record time for a UN convention, for a UN agreement, and it came into force less than a year later after the original Paris meeting. So that's what the countries have agreed to do. Now, how far are they along the line in this? So this is the sort of business as usual curve up there. And if you take what the countries have agreed to, it probably takes us somewhere about there. Now, if we're going to go to 2 degrees or 1.5 degrees, I should say this is emissions of greenhouse gases, and these are years along the bottom. So this is through to 2030. So if we're going to keep it at 1.5 or 2 degrees, we should be somewhere down here. This is what the agreement is at present. So clearly, it's a good start, but it only takes us about a third of the way we've got to go. So a lot more needs to be done. I wanted to, and individual countries are doing things. Now, the Paris Agreement was in 2015. This is one where I'm actually quite proud of my country. I'm often not, but in this one I am, that in 2008, our Parliament agreed to this Climate Change Act, and it went through Parliament, with 450 voting for it and 3 voting against. You don't often get parliaments agreeing that much. So it went through with almost no disagreement, and it pledged the UK to an 80% reduction by 2050. So taking us from 10 tons of carbon dioxide per person per year down to 2. Now, that's quite a reduction, but not just a 2050 target, but setting 5-year targets from 2008 onwards. So the government has got to set targets, and we have targets already set to 2030. And the 2030 target is a 57% reduction. So the targets at the moment are being met, and the government of the day is required to develop policies and proposals to meet the budgets. So not just the present budget, but they must have the policies in place to actually get the future budgets. And this is a legal requirement, and they are open to judicial challenge if they're not working towards those. And they established an independent advisory body, the Committee on Climate Change, which I've been on for 10 years, actually. I'm just due to come off. But we advise the government and Parliament on the targets, and so far they've all been accepted. We monitor how the UK is doing and how the government is doing on policies and report to Parliament. So, and this Climate Change Act is now being mirrored in a number of other countries and pledging this sort of reduction or more, because it now appears this 80% reduction that in 2008 seemed to be a good target. We probably need to go higher than that, maybe 90% or 100% by 2050. But it's pushing us into the right area. The EU presently only has a 40% reduction target by 2030, but the EU feels strains between Eastern Europe with the fossil fuels and Western Europe that would like to go faster. Now, technology is a huge part of whether we can tackle this challenge. I've put in one thing about the growth of railways, and there's Stephenson's rocket on the left in 1829, and you see the rise in passenger curves from there. So essentially, once this worked, it's amazing the feedback the positive feedback loops that develops once a technology is tried, once it's being successful, the economics are there, and even inspires art as well. And that's the passenger rises there. But other things, the mobile phone. I remember we organized a conference in about 1980, and we had this huge object which was called a mobile phone. And its battery needed to be charged every half an hour, and now we have these things here. Now, once the technology was developing, and then the change was just huge. We've already seen this too in cars. For me, an electric vehicle is a milk float, something that delivers milk around. But now we see the Tesla in particular has taken this to a new dimension. And even Ferrari, I gather, is now testing an electric vehicle. So suddenly, from being something that was not anything that anyone who was smooth or cool would think about, I tell my neighbors now, if you want to get a vroom vroom, you can have earphones. And you can get a vroom when you press the pedal. But what should happen is just a quiet whoosh as you go along. You press the pedal on a Tesla, an amazing experience with no noise. You just whoosh. So that's the future. We're not dealing with the past. This is the future. And solar power, solar PV, the photovoltaics, the cost of those has plummeted. And I should have updated this because it's now down here. In many countries of the world, it's the cheapest form of electricity. And you can think of the new dimension that opens for somewhere like India. You no longer need to put in this central power station with the infrastructure going down to the village. The village can have its own photovoltaics and just deal with its own system. And it can have local ownership and all the differences that goes along with that. So in many ways, the developing world can leapfrog the technologies that we've been through, and they no longer have all this power stations, etc., to deal with, and all the infrastructure that may hold us back. But of course, they'll need money to do it. So it's a challenge to business, working out the risks of climate change, increasingly the threat of divestment, whether investments are going to move away from the old industries, the old polluting industries. But then, of course, the major opportunities for new industries, as I've been suggesting in the previous thing. So a lot of the top companies have set their own carbon intensity reduction goals. And this is the sort of rate globally we've got to reduce emissions. And a lot of countries are now, companies are thinking of that. A big company like Unilever has been in the vanguard of this, of actually thinking about sustainability, not just as an add-on, but as a central plank to their industry. And Bill Gates and co. invest early, broadly, boldly, wisely, and together. That's the spirit. And a challenge to politics. I'm going to give two examples from Margaret Thatcher, who is not exactly my favorite politician, but she is well known. And she made the most amazing speech. This was actually, this is the Royal Society one, but she gave one to the UN in 1989, which you can get on YouTube, and it's a most fantastic speech. It's better than any politician today can give. So to the Royal Society in 1988, she said about stable prosperity achieved provided the environment is nurtured and safeguarded. Protecting the balance of nature is therefore one of the great challenges of the late 20th century. And she had some good advisors there, and she really started climate change as a big thing to think about in the UK, in science and in politics. Then she wrote in her later life, when I think her mental powers were not as good, but I'm biased, and she was advised by different people, she wrote a different story here. The doomster's favourite subject today is climate change. This has a number of attractions for them. The science is extremely obscure. I try to persuade you it isn't. But anyway, and since this is the crunch, since clearly no plan to alter climate change could be considered on anything but a global scale, It provides a marvelous excuse for worldwide supranational socialism. Okay? So you cannot do anything about mitigating climate change without some agreement to regulate the emissions. And this is then seen by Margaret Thatcher in her later days as something, the Berlin Wall had fallen, so what could the left think about? But now they could think about climate change and how to keep everyone under control with climate change. So this is the danger when it gets politicized like this. And I've been in discussions with certain politicians in the UK, and this is one of the things thrown at us. I'm going to give you two. The proposed measures will ruin our economy. I would now say quite the opposite. If we continue on with the economy of the past, then we're just going to go down and down. Actually, the new challenge is going to give new opportunities, and those are the industries of the future. So if we want a sustained economy, we have to go this way. This is the way it's going. Then the other one, from politicians who have never cared in the past about the poorer countries, but suddenly they're really very concerned about them. And how dare you inhibit the growth of these? Why not let them do what we've done, become rich using fossil fuels? Well, again, I think it's quite the opposite, because they're going to be hardest hit by climate change. And as I've suggested, the new technologies enable them to leapfrog to a much more sustainable development, but they will need the help to do it. So it is a challenge to politics, it's a challenge to society, because as human beings, we're very good at thinking of ourselves now. We can extend that to our family and thinking of the next decade or so. We can extend it to our village, perhaps, and thinking of 30 years' time. Can we extend it to the whole world and maybe future generations? It is a challenge to our species to do this. Can we think from the short term to the long term? And lots of our behavior is determined by all sorts of things that are almost built into us in terms of our development, our attitudes, and our beliefs. So somehow we have to get internationally this shared aspiration of where we wish to be. And Paris, to a certain extent, was an idea that really was being done. But of course, it hasn't actually happened yet, so we need it to happen. So these are my final comments, which are perhaps a summary. We know we're doing something dangerous to our planet and dangerous to us on this planet. Now, in terms of climate science, which is my area, then quantifying the risk for a particular scenario of human activity is a challenge to us to define what that risk is and try and quantify it. The technologies, there's a huge technology challenge and a spur to the new industries. So that's really real stimulation of technology, of innovation. And it's a challenge to our social, economic, and political ways of working. The economics is in there and the whole way we've been talking about this. It's meeting these challenges, we really will need imagination, determination, and leadership. And sometimes we lack 1, 2, or 3 of these. Will we meet this challenge? Am I optimistic? I think so. Thank you.
Okay. Thank you very much. It was very interesting. I'm sure we have questions from the audience.
Okay. Thank you for. Thank you for the lecture.
Thank you.
My question relates to the final point, because you have mentioned the social development goals, which is a very broad research, a very broad policy agenda, quite diffuse, because
Sorry, I missed the first bit. So you mentioned
the social development goals of the United Nations. So this is
Sustainable Development Goals.
Sustainable Development Goals. So this is a broad policy agenda.
Yeah.
It is quite diffuse because, of course, there are a lot of nice things there, but it's very unclear how you get there and so on. And so my concern is that if we use this type of approach that are rather diffuse, we are actually going to drift away from instead more tight type of intervention, which you were, for example, the one taken in Britain, which seems more, maybe more focused, but much more effective in tackling climate change. So I would like to know your reaction on this.
Yes. I mean, that is a good point. And to me, climate change is such an evident problem and such an important one. It's clear that it has to be tackled, and the opportunities are great. But in many ways, getting a new audience to think about this, if I take health, for instance, which is one of the Sustainable Development Goals, thinking about the implications and the link with the health issue is an important way of some people approaching this problem. So in the UK, for instance, there is the journal called The Lancet, but there is the Lancet Countdown, which is the medical community actually coming on board and saying that climate change is a major health problem. And that is making quite a major impact in terms of actually the Department of Health in government now says, oh, perhaps this isn't just another ministry's problem. We should take this on board as well and perhaps be more supportive of their actions. And in the spread of malaria is a very good way of influencing many people in Europe, for instance, that this is that just a warmer climate is not perhaps all good news. Maybe not in Italy, but there's some seaside resorts in the UK would say 5 or 10 degrees warmer, that sounds pretty good to me. You say, well, okay, there might be malaria coming along as well, but that doesn't sound quite so good. So I think if you link with other issues, feeding the world, feeding the world, the link between food, agriculture, and climate change is so large that by linking those issues you can again bring home that with 10 billion people, how are we going to feed them if the world is 5 or 10 degrees warmer? Again, it just brings home the problem. And as I say, if you can tackle more of those problems at once without diluting what you're doing, but there may be options. You could say, well, I could tackle this in climate change in this manner or this manner. And if this one is then more supportive of another UN Sustainable Development Goal, let's go that way.
Yep.
What happens to your scenarios if there is some global event that can suddenly induce a climate change? I think to a huge volcanic eruption, like Tambora at the beginning of 19th century that caused a year without a summer, or a sudden release of methane from methane hydrate deposits, or an overturn of ocean circulation that is possible since the ocean bottom water has now the maximum possible density. So how to take advantage of this kind of global event that can enhance the changes in a sudden way?
Yes, I mean, you talk about the volcanic, let me take the volcanic eruptions. Then the huge volcanic eruptions could influence the climate of the Earth for a typical strong volcanic eruption can change the temperature for 1 or 2 years. If there's a major set of eruptions, those can influence the temperature over, a couple of decades. I wouldn't like to make the future of this planet and our life on it dependent on the hope that there may be a succession of volcanic eruptions that will hold the problem back, because that's all they would do. Once those volcanic eruptions stopped, then you would realize all that extra greenhouse gas and the warming that goes on. I'm a scientist, and I never say I'm 100% certain of anything, which is very difficult interacting with politicians who are always 100% sure of everything. And I would say there's a 1 or 2% probability that climate change is not as big a problem as I've suggested it is, and that there may be something else that will compensate. We don't know what that is, and we have no sign of it, and I wouldn't like to pledge the future of my grandchildren on the hope that that 1 or 2% comes about. Anyway, we've had the fossil fuel era. All we're doing, fossil fuel era would have been over by the end of this century. All we're doing is bringing forward the end of the fossil fuel era. So it's not a dramatic change. We had slavery. That's how Europeans got extra energy, was by using other people, slaves. And we had child labor. And people said, well, we can't do without that. But we seem to manage to do without slaves and child labor. Again, that partly because we found fossil fuel to do the work for us. And that is needed for a while, but then we found new technologies to get round fossil fuel. So it's part of the development of our human species and our ways of finding energy we're using on to the next level that is less polluting to our planet than the previous level. It doesn't do any harm to move to these new technologies. Why not?
I would like to know your opinion about the necessity of constraining our predictive model of future climate change against sound reconstructions of past climatic change fluctuations.
Okay. I think it is very important that we use all the information we can to help us give the best possible future projections of climate. And past the history of the climate on our planet is the only data we have for evaluating how good the models are. And they have been evaluated with a lot over the last 100 years or so, and the variations in climate then, which are generally not so big. As you go back further into the past, the knowledge of exactly what the climate is like becomes less, but the changes become bigger. And so it is very important to get the best possible evidence of what climate was like in the past and to evaluate the models on those past climates, both as snapshots, this is what the climate was like, but then in terms of changes, as I was suggesting at one point, the models are not able to get the change through to the Green Sahara. And that was the change through to 6,000 years ago. And the models cannot move the edge of the vegetation that far. So that is a problem. I'm suggesting the models are too sticky in some ways. But evaluating models over a whole ice age cycle is very important to do. The difficulty is that the state-of-the-art models that are used for the projections I showed you can only be used in less detailed form for such long, if you're going to integrate over 100,000 years to look at an ice age cycle. So you have to make some simplifications in them if you want to look at very long time scales in the past. But it's extremely important to do, yes.
Yep.
Thank you for your interesting presentation. I would like to know your feeling about the following issue. I totally agree that the challenge of climate change to be addressed requires the collaboration of different scientists from different fields, climatologists to understand how our climate system works, engineers to understand how our energy technology works, and then people from the social sciences to understand how these changes might affect our societies, our economies. My feeling is that natural scientists have done a much better job than social scientists on average.
Of course.
Okay.
This is one of the UN Sustainable Development Goals, yes.
Yeah, but then in the end, when it comes to politics, to international agreements, the impact of climate change on societies is important, and this is evaluated through socioeconomic models. So we probably need a way to reframe our way of evaluating climate impacts. So I believe that we need a much broader connection between these different scientists in order to better, to ameliorate our model and better address our goals. Because what I noticed from the point of view of an economist is that even though, for example, in my group we get results that are much more similar to what I can infer from your positions, so for example, very large impacts from climate change that might change the growth trajectories of our economies. What you find in the top journals is that climate change is something like, okay, under an RCP 8.5, we are going to have another financial crisis. The cost to society is similar. I don't believe so, no. But the problem is that who cares about economic journals? It's not important. But now this way of modeling things is moving gradually also to other journals, other scientific communities. I find papers in Nature Climate Change, I find paper in PNAS, I find paper in Science using this approach. So my feeling is that we need a closer collaboration in order to review our evaluation of climate impacts. So from the point of view of a natural scientist, I wanted an opinion.
Yep. Well, let me give you one statement which actually suggests what my view is. Some 10 years ago, I moved to take on this new institute at Imperial College. That was sitting in Imperial College between the natural sciences, the engineers, the medical faculty, and the business school. And it had it later developed a sister institute in the London School of Economics with Lord Stern, Nick Stern as the chair of that one. And so we have the social science economics linking across the whole thing. So I moved to that exactly like you say, because I thought this was extremely important. For many years, I've been as a climate scientist speaking, well, this is what our information says, and you feel it's falling on deaf ears because the world does not really receive, because the scientists can say more, refine their views more and more, but it's still not going to change anything. And it is only when you get that link across. But if I, as a climate scientist, hand over the data there, and then an economist comes from here and takes that data, they don't know what's in that. It has to be a live communication that really does not lead to those models, which is very smooth behavior and it's sort of the economy can survive. I mean, I hear this from the economists that they do have trouble with the traditional journals, which have not looked on this as respectable economics. But increasingly they're doing so, I gather. But yes, I mean, it is incredibly important to get that interaction. And my thing at Imperial has been to actually not broaden, but become shallow. The danger is when broadening becomes shallow, then you get the science, the engineering, the economics is no longer any good. What you've got to have is the 5-star scientist, economic, social scientist, interacting and able to talk together. And that's what we try and do in the institutes, and I'm sure that's what you'll try and do here.
Now, I'm connecting with the previous question. I was thinking, don't you think we have also a big problem regarding communication? Your presentation was really brilliant and it was really clear. And I also had some anxious listening at you, you know, and it was clear. But when you go to the population, to the media, how can we pass this message? I think this period is very different from the previous one. And scientists have a big problem when they have to communicate.
Yep.
And what about, you know, the issue about fake news and so on? I think that we have to think about this, because otherwise we can have the scientists working together, but then we don't pass the message.
Yep. At my institute at Imperial, there is a director of policy. There is two people working on the media relationship. And I totally agree with you. It's incredibly important, and we've been very bad at it in the past. I think, harking back to a previous question, the link with things like health, agriculture, food, flooding, the fact that things people experience is a good way of actually getting a message across. If I say as a climate scientist, well, the temperature is going to go up they'll get more heavy rainfall, what does that mean? But if actually it comes through various other things that they're more aware of, then maybe that's one of the ways through. But I totally agree with you. We really have to think about the communication. We are doing so, and we have to find new ways of doing this. And that the newspapers now are less helpful than they were 20 years ago in doing that. And the media that wants an immediate story, we have a problem. I mean, I get called up, and when there's been some extreme rainfall or whatever, and they say, can we say this is climate change? And I say, well, you can't say that this is climate change, but it's the sort of thing we might expect more of with climate change. And by that time, they've gone to someone else who will tell them it's climate change or it isn't. You know, so this scientist clearly is not able to communicate. So somehow getting away from this, the story we've had in the past of saying these things are more likely, to actually being able to get through to communicate the information but not make it sound so vague in a world where everything is so definite. As I said, politicians are always 100% sure, and the media tends to follow them these days 100%, either following that or that. And somehow we've got to get through that world. Very difficult.
Yes, I'm linking to the previous comment, because I also had the same feeling as she explained. I mean, when I was listening to you and I already knew part of the story, then it is unavoidable that you get a little bit scared. So I think that we should avoid to get into the Cassandra syndrome, because that is negative. So together with explaining what is the situation and what might happen, we also should provide what we can immediately do.
Yeah. What we can immediately do.
Yes.
Yeah,
yes. Absolutely.
And in talks I give to the public, I try and give, I'm asked, well, what can I do? And I said, well, you buy a refrigerator sometimes. Do you go for the A++++, as many plus as you can get? When you buy your car, do you really look at how flashy it is, or how many kilometers per litre it does, litres per kilometre, whatever? As a citizen, you vote. Have you told your representative in Parliament that you think this is an important issue? So I do try and actually communicate what individuals can do, because I think that's very important. But I think the technologies as well are making this a lot easier to communicate. This is the exciting thing. And this is a difference actually over the last decade. I gave my first public talk on climate change in 1985, even though I wasn't researching in that area. But it was very difficult until the last few years to really say, this is the exciting future. The technologies have developed now such that people are aware that their mobile phone is now an exciting object to have, and that electric car, and the solar PV or on your roof is now cheaper than the something you're getting down the line. And this has changed things, that it's actually, I think I mentioned my neighbours in my street at home. They're not interested in my things on global warming. They are interested in the technology of the electric car I have in my garage, the photovoltaics on my roof. It's starting to get to be the exciting area to be in as well. So I think we have a number of ways around to do this now.
Okay.
The Cassandra syndrome seems to me to be unavoidable, objectively, for the time being. Because in the present state of Western democracies, in which decision-making is absolutely unable to look into the future, to take care of the wants and rights of future generations, the role of scientists and of enlightened people of other disciplines can only be to play this Cassandra syndrome, which is not only, on the other hand, it is not just a Cassandra syndrome, we should say, because without some degree of conviction among politicians and parties and sections of public opinion, the Paris climate agreement would have never come into being. And this seems to be, it has originated a political struggle which is now flourishing on the two sides of the Atlantic. But this seems to be one way out of the pure and desperate Cassandra situation.
Yes, I don't think the politics of the last few years have made me more optimistic than I was before, rather the opposite. But I said I think I'm optimistic, and we have our populist moment. In terms of the people behind these populist movements, if the money is to be made in these new industries, maybe that will help a lot of these things actually happen. So there are various pressure points that may encourage this. And in the US, Donald Trump has talked about resurrecting the coal industry, but the market is no longer there for the coal. And California, the East Coast, the West Coast, see the technology, the economic opportunities, and the big US corporations in general see the new opportunities. So maybe the politicians like Trump will almost be left behind and become irrelevant in what is starting to happen anyway. That has got to be a hope, because I don't expect people like him will suddenly be converted and take a new drive in saying climate change is my big new movement. It's not going to happen, but I think there's almost a whole inertia, forward momentum to this now, that it may be happening around them. A lot may depend, though, on how willing the West is to provide the help, financial and technological, to the developing world to help them into the new sustainable development process. And it may be that is where we might be in trouble in the direction we take. The Western world might be taking the direction because it just happens rather naturally, but the developing world needs help to do it, and that's financial help as well, and that's at risk at the moment.
Now, I have a final question about the possible role of photosynthetic organisms in counteracting the rise in CO2 level into the atmosphere. In theory, photosynthetic organisms should benefit from a rise in CO2 in the atmosphere. Granted, the temperature increase will not counterbalance this advantage. So I think that in theory, organisms living in the oceans where the rise in temperature is lower than elsewhere might, in the end, increase their activity and might contribute to blocking a certain amount of CO2 back into the oceans. So my question is this already happening? And therefore, the curve we see is that one because ocean living organisms, photosynthetic organisms, are already keeping the curve low, or do we expect that the threshold for seeing the effect is not reached yet, and we might at a certain point observe a a different trend in the rise of, temperature and, of course, CO2 because of a beneficial impact of photosynthetic organisms using the CO2.
Okay. On the land surface, there is certainly evidence that there has been a growth in vegetation associated with a higher CO2. In terms of crops, the ambient rainfall, irrigation, etc., becomes more important. So the levels we see in the atmosphere might have been slightly higher, but for this growth in the vegetation. I think we're only looking at a rather marginal decrease, and part of the picture I flashed past was to encourage both the land surface and the vegetation to take on more. In the ocean, one of the plans was to try and encourage the biology to take on more, but often there's the deficiency in minerals. Yeah. So one of the plans was to put iron on the ocean and scatter iron and watch the bloom in the ocean, which happened for a while. The ecosystem changed because the balance changed, but I think the impact on the CO2 so far has been really rather small. So I don't look on that as a solution. It might help us at the percentile level, but not too much, I think.
Okay, so thank you very much to Professor Hoskins for his great talk. I would like to also to thank Professor Roberto Buizza for organizing this first workshop on climate change. The next one will be held at the Scuola Normale before summer. The third one will be held in Pavia at the youth school. Therefore, we look forward for the next workshop. And again, thank you very much to the organizer, to the speaker, and to all of you for participating to today's conference. Thank you very much.